Hello everyone, welcome to the advanced communication sessions. This is the session 10. In this today's particular session, we are going to learn about the aircraft landing system. The contents which we are going to cover: the instrument landing system and the ground control approach system here. These are the two types of the landing systems which we are going to learn in this particular session. First one is the instrument landing system. That is, in case of the instrument landing system, landing an aircraft in the low visibility, that is in the bad weather conditions, it is very difficult for the pilot to judgment. That is, where is the runway there. In those conditions, the instrument landing system, it will help the pilots such that they can take the correct route and they can land the aircraft safely here. That is the one of the method that is called as the instrument landing system here. This system enables the flight deck crew to locate the runway even in the bad weather conditions here. The instrument landing system makes use of the lateral and the vertical guidance to lead the aircraft down the runway. Lateral and the vertical guidance means what? It is giving the guidance about the horizontal plane as well as the vertical plane here. That is to take the correct path and to reach the runway properly. It is guiding the pilots such that they can take the vertical as well as the horizontal points correctly here. Now the part which is handling this lateral issues, that is called as the localizer oscillator here. That is the localizer server, that is LOC. It is guiding in the horizontal plane here. While the glide slope acts as the vertical guidance, means it is providing this particular instrument landing system. It is providing the pilot both the planes here, horizontal as well as the vertical. The LOC, that is the localizer, it is providing the horizontal guidance, while the glide slope, it is providing the vertical guidance here. Now this is the diagram for the instrument landing system here. If you observe here, this is the runway. This black color strip, it is the runway here, and this is the starting point of the runway. This is the end point of the runway here. This is the starting point of the runway. This is the end point of the runway. And in this instrument landing system, the different transmitters and the sections are used and the receivers are used here. First one is the localizer transmitter. If you observe here, it is the localizer transmitter which is situated away from the end of the runway. This is the end point of the runway. If you observe here, this is the end point of the runway. Away from this at some distance, the localizer transmitter is situated. And if you observe here, this is the glide slope transmitter here. The glide slope transmitter, it is located at some point from the start of the runway here. At the one side of the runway, at the start of the runway, the glide slope transmitter is located. Now the localizer oscillator, it is generating the frequencies such that it is generating one vertical plane here. If you observe here, this vertical plane, it is generating one vertical plane. Now here the glide slope oscillator, it is generating one plane such that it is inclined at an angle of 2 to 5 degrees to the horizontal plane. This where if you observe here, this is the vertical plane which is generated by the localizer transmitter signal. The vertical plane is generated by the localizer transmitter signal. Similarly, this plane, it is inclined at an angle of 2 to 5 degrees. Usually in the range of the 3 degrees it will be there. It is inclined to the horizontal plane, and this plane is generated by glide slope transmitter here. Glide slope transmitter. Now the intersection of these two planes, where they are intersecting. Here is the one is the intersection point, and one more is the here. The intersection of this vertical plane and this inclined plane, where those are intersecting, that those points are joined, and that gives the path for the aircraft here. Means the aircraft should follow this particular dotted line here. The aircraft should follow this particular dotted line. Again, to verify whether the aircraft is following this dotted line, we are having 3 marker beacons here. Correct? 3 marker beacons. So first one is the inner marker, middle marker, and the outer marker here. Inner marker, middle marker and the outer marker. All these three are having the same frequency here. All are generating the same frequency, and at the aircraft also to receive these frequencies, single receiver is there. Single receiver is there. Now whenever the aircraft enters here using this particular line, if the aircraft tilts from this dotted line, if it is going away from the dotted line, either this side or this side, then that arrow mark on the instrument indicates there. The particular aircraft, it is moving from the away from the this one here. For example, if you consider this is the particular indicator will be there, and here the arrow mark will be there. If it is the aircraft is following the particular dotted line correctly, means it is on the exactly center here. If the aircraft is tilting away from this dotted line, means what will happen? The arrow mark will be either in this direction or in this direction. It is not at the center here. Then the pilots will came to know that okay, now it has tilted. Again they will bring to the dotted line such that again it will follow this dotted line only here. Now if you analyze here, this localizer, it is providing the signals which is giving this vertical plane. This glide slope transmitter, it is providing the signal which is giving this tilted plane, and it is tilted at an angle of 2 to 5 degree with the horizontal plane, usually 3 degrees here. Now again we are having three marker beacons here, inner, middle and the outer marker beacons. All are generating same frequency. To receive these frequency at the aircraft, we are having the same receiver here. Now whenever the aeroplane enters into this region, in the inner marker, what will happen? One beep will be generated. That indicates the aircraft has entered the particular M1 region. That beep will be generated as well, one light will be displayed there. Similarly, when the aircraft enters into the M2 region, then again one more beep will be generated and the different color light will be displayed there. Now it has entered into M2. For example, here green, yellow, white, like that. Different color the displays are there. Again, when the aircraft enters into the third marker beacon, that indicates here it is entered into the third marker here, and also it is a particular display will be generated there. Therefore, now the pilot will came to know that okay, now they are following the correct path here. They are not away from the runway here. Slowly they will enter, and after receiving all the three signals, they will touch the runway point here. They will touch the runway point. Therefore, this is the procedure here. Means the localizer, the particular this instrument landing system, it is guiding the pilots in the poor visibility such that safely they can land the aircraft here. Now just we will go through the specifications, what frequency all these are generating and at what distance they are there. Now see here, localizer transmitter, it is there situated at 300 meter away from the runway end point. 300 meter distance, and what is the frequency here? 108 to 112 megahertz. That is here it is situated 300 meters here. Distance is 300 meter and the frequency generated by this transmitter is 108 to 112 megahertz. Right? Now if you observe the glide slope transmitter here, this will be situated in the one side of the runway at the start point here. One side of the runway at the start of the runway, and frequency how much it is generating? 330 megahertz. It is generating the frequency 330 megahertz, and we are having the three markers there. One is the inner marker, middle marker and the outer marker. Inner marker, it is situated at 60 meter from the start of the runway. Middle marker, it is 1 kilometer, and the outer marker is 8 to 10 kilometer away from the start of the runway here. All the three, that is 60 meter, 1 kilometer. Here it is distance. It is the 60 meter from here to here. It is 60 meter. From here to here, it is from this point to this point. It is 1 kilometer. Again, from this point to this point, it is 8 to 10 kilometers here. The distance. Next, the particular frequency. All are generating the same frequency here. All are generating the same frequency. Therefore, it is 75 megahertz here. Okay, now these are the some of the specification of those localizer, transmitter, glide slope transmitter and those marker beacons here. Now this is the diagram here again. From the runway, the different three marker beacons are there and the localizer is there and the glide slope is present here. Same diagram here. Just observe the video here. We can make out.
ILS. In this video, we will learn about navigational aid, called as instrument landing system. Instrument landing system is correct. These are used for providing safe landings during instrument meteorological conditions or IMC, such as low ceilings or reduced visibility due to rain, fog, or blowing snow. The ground equipment comprises of two highly directional transmitting systems, called as the localizer and glide slope, and three marker beacons. Localizer is an antenna array, normally located beyond the departure end of the runway. These generally consist of several pairs of directional antennas, which transmits two signals. Each antenna transmits a narrow beam, one slightly to the left of the runway center line, the other slightly to the right. It gives azimuth information and indicates whether the aircraft is on left or right of runway center line. A glide slope station is an antenna array sited on one side of the runway touchdown zone, approximately 150 meters away. It provides vertical guidance for elevation and indicates whether the aircraft is above or below the glide path for the approach. This ensures that the aircraft is following the glide path and remain above obstructions and reach the runway at the proper touchdown point. The pilot controls the aircraft so that the glide slope indicator and localizer needle remain centered on the display to ensure the proper landing. In addition to the localizer and glide slope, the ILS is typically equipped with marker beacons to assist pilots in identifying their location on approach, known as the outer marker or OM, middle marker or MM, and an inner marker or IM. The outer marker is typically located from 5 to 7 miles from the end of the runway threshold. The middle marker indicates a position approximately 3,500 feet from the runway threshold. An inner marker depicts a position approximately at a distance of 1,000 feet or 300 meters from the threshold. When the aircraft passes outer beacon overhead, a vertically emitted radio signal activates a rapidly flashing blue light on the aircraft's marker beacon receiver. It also produces an audio signal, which is 2 Morse code dashes per second at a low tone. Middle marker is typically the location where an aircraft on approach will be at an altitude of approximately 200 feet above the elevation of the landing area. This system enables pilots to visually identify the runway either by pavement or with the assistance of an associated approach lighting system. This marker's audio signal is a series of alternating Morse code dots and dashes in a high tone. When the plane passes overhead and an inner marker or IM, aircraft's marker beacon receiver flashes a white light in unison with the received audio code. The marker's audio signal is a repeated Morse-style dot at 3 kHz. I hope you well understood about instrument landing system.
Okay. Now let us move on to the Next one, that is the ground controlled approach here. In case of the instrument landing system, all the whatever the informations are there, those are given by the instruments only. That is the localizer and the glide slope oscillator here. They are generating the signal and the marker beacons are there. Depending on those received signals frequencies, the pilots will take the decision. But in case of the ground control approach, it is something different here. That is from the ground station, orally the persons will give the instructions to the pilots here. This is the one of the earlier methods here. It is one of the earlier method here. The persons will give the instructions to the pilot such that whether their path is correct, whether they are taking the correct path or not, and where to take a safe path. All those are guided here. Therefore, in case of this ground controlled approach, it is making use of the two radars here. One is the search radar equipment, and other is the precision approach radar here. The ground control is making use of the two radars, search radar and the precision approach here. The particular ground control approach is the oldest air traffic technique to fully implement radar to service a plane here. The system was simple, direct, and worked well even with the previously untrained pilots here, because all the instructions are given from the ground stations here or the earth stations here. It requires close communication between ground-based air traffic controllers and pilots in approaching the aircraft here. Means here the communication is required from the air pilots and the staff who are present at the ground station. They should communicate continuously to land the aircraft here. Now, suppose for example here, if the aircraft it is trying to land, means from the ground station or the earth station, the persons are observing on the monitor there. Through the search radar, they are observing where the position, and from here only they will give the instructions. What was their position, whether they are in the safest region or they are approaching the particular landing or not, like that they are given, and continuously the pilots will communicate with the ground station staff here, and they can land the aircraft here. Now in the ground control approach, the general surveillance radar or the search radar equipment, what is the main purpose here? It searches the particular aircraft and it displays on the PPI display. Round display will be there, no? Already we have studied the PPI and the A-scope display. On that PPI display, it is displayed there. And afterwards, once it is searched there, a high resolution short range set is used to conduct the landing here. That is the precision approach radar. As I said, there are two radars are there. One is the search radar and the other is the precision approach radar to land the aircraft here. These are the two methods for the controlling here. Now, what is the merit here of the GCA? No equipment is required in the aircraft other than any ordinary radio transceiver. That's only they should transmit their voice and they should receive the voice signals here. Other than that, they should not need anything here. And the demerit is what? The coordination is difficult as a number of human beings are involved, because the number of human beings are involved here. They are sending the information towards the aircraft and they are receiving here. Therefore, there may be chances of some confusions also here. That is one of the demerit here. Now, let us move on to the MCQ here. What is the full form of ILS? That is, what is the full form of ILS? It is the inclined landing system, the instrument landing system or the immediate landing system. And the answer is, it is the C. That is the instrument landing system here. ILS operates as a dash-based instrument approach system, ground, air, sky and water. It is the ground-based here. The localizer provides the guidance. Lateral here, horizontal guidance here. A localizer is generally located beyond which end of a runway? Localizer, where it is situated here? It is the departure, end of the runway here. Part of the following is the lateral component of the ILS. That is glide slope, localizer, beacon and the gyro pump here. That is the lateral, means horizontal component, which is that B, localizer. It is giving the horizontal guidance here. The LOC signal is in the range of 1110 megahertz. What is the frequency range of LOC carrier frequencies? It is a 108 to 111 here. The pilot controls the aircraft such that the glide slope indicator remains in the center of the display. True or false? It is true here. Glide slope transmitter operates at a frequency of, it is C, 330 megahertz. Okay, thank you. We will continue in the next session.